Welcome to physics class. In today's video, we'll be concentrating on a brand new topic, heat energy 1. And so we'll be looking at the concepts of heat and temperature. Also be looking at the effects of heat on matter, rise in temperature, change of state slash first, expansion etc. We'll also be looking at heat transfer, conduction, convection, and radiation. Quickly, by the end of this class, you should be able to explain the concepts of heat and temperature, list and explain various effects of heat on substances, explain comprehensively with suitable diagram change of states, states the kinetic molecular theory, list and explain the various modes of heat transfer. Of heat energy, heat energy transfer. So let's begin. Heat energy is one of the concepts with which the study of physics revolves around. As a well-known fact, it is the ability or the capacity to do work. In our previous lesson, we were introduced to the various forms of energy to which heat energy was inclusive. If you remember in our first meeting on the subject physics, we defined physics as a natural science that has to do with the study of matter, its motion through space-time, and with the concepts such as energy and force. So there are various forms of energy. We have looked at various forms of energy in our previous class. We have looked at potential energy, that is, potential energy and kinetic energy, and other forms of energy. So we, in this video, want to concentrate on heat energy, the effect of heat energy on matter. And you know, matter is anything that has mass and can also occupy space. So let us quickly look at what we have here. Concept of heat and temperature. Heat or thermal energy is a form of energy that is gotten from different sources. It could be gotten from the burning of wood or coal, sun, decomposition of organic matters, etc. It is a form of energy that affects a body through direct or indirect contact. For you, we agree with me that you do not need a direct contact with the sun to get warmed. Hence, based on this preamble, we can confidently say that heat energy is a form of energy in motion that flows from a hot region, probably the source, to a cold region, and vice versa is never the case. Heat energy is a form of energy that flows from the region of high temperature to the region of low temperature. This happens because of the difference in the temperature in the system. If the two systems has a difference in temperature, one high and one low, heat will probably flow from the high source down to the low source, and so the vice versa will never be the case. Vice versa will never be the case. So this is what we mean. The thermal or heat energy moves from warm to cold. It is always from this place to this place and never from cold to hot. You can see from this tea is steaming up here, not from up to down, but from down to up. And so the sense is from here to here, and then from here to here. So this means that heat and temperature are directly proportional to each other. That is to say, the increase in the quantity of heat will result to increase in the temperature of the body, and a decrease in the quantity of heat will as well result to the decrease in the temperature of the body. What do we mean by these statements? Increase in temperature connotes, increase in heat energy connotes increase in temperature. This happens in a normal day, like today. It rained today, so the temperature was very low today. And then on a very hot sunny day, you see yourself sweating, telling you that the temperature of the day is high, and the weather of the day is high, or the temperature of the day is high, and then it affects your body system by raising the energy level in the molecule of your system. That is your the kinetic energy, I mean the molecules of your system that make up your system are being charged up by the environment, and then they move randomly, hence making sweat to come out of your body. That is what we mean by this statement. So what is temperature? Temperature is always defined as the degree of hotness or coldness of a body. When the body is low, we say the temperature is low. And when the body is high, when the temperature of the body is high, we say the temperature is high. So temperature is simply the degree of hotness or coldness of a body. Temperature of a body system is measured using the instrument called thermometer. So quickly look at this. So if you want to copy it in your notes, temperature is measured in the unit of degrees Celsius. Degrees Celsius is the unit of temperature, or Kelvin, or degree Fahrenheit. We have we have three units. We have degree Celsius, degree Fahrenheit, and then Kelvin. You don't call it degree Kelvin. You have Kelvin, degree Celsius, and then degree Fahrenheit. I want you to take note of this quickly. We want to quickly look at effects of heat on a system. Of course, when heat is added to a system, the system will not remain the same. As I'm sitting here right now, if I expose myself to heat, I will, you see me be using this handkerchief to clean the sweat from my face. And so addition of heat to a system brings a lot of changes in that system. We want to quickly look at that right now. So we say that change in temperature. Change in temperature means high or low. The body may increase in temperature or decrease in temperature. The body only increases in temperature when the heat is added to the system. And then when the heat is removed from the system, the body temperature falls down. Change in state of the body. We'll look at this shortly. We'll look at change in state also in today's video. Change in state of the body is a subtopic of its own, so we cannot treat it here right now. Expansion of the body. Expansion of our body will be treated in our next video, where we're looking at linear expansivity, area or superficial expansivity, volume or cubic expansivity. Change in the physical properties of the body. Matter has chemical properties and also physical properties. Thermonic emission, chemical change, and then change in pressure. I would like to uh, discuss this one quickly. Let me touch this one quickly. Thermonic emission is a situation where heat is matter is a situation where matter, maybe a metallic object, gain heat energy and then it is able to emit photon of light or energy. We will treat this comprehensively in what we call energy quantization, that is quantum physics at the secondary school level. So we look at also chemical changes. There are chemical changes when heat is added to a system. For instance, if I decide to burn this will turn to ashes. That is the chemical system. That is the change in the chemical system. It will turn to ashes. And then if again I try to, in fact, changes due to chemical changes are hardly reversible changes, while the other changes can easily be reversed. Here, change in pressure. When you add heat to a system, you increase the pressure of that system, and then when you also remove heat, you also remove the pressure in that system. This is what happened in the topic gas law, where we treat uh, Charles law and Boyle's law, where we say that Boyle's law has to do with the increase in pressure, which connote increase in volume. So, for instance, the pump we use to inflate air in the tube of the tire, if you keep pumping, you see that if you touch the pump, you feel that the pump is very very hot, and then inside the air molecule inside decide to rise up and then increase the pressure in the pump. So these are the various effects of heat on a system. We want to quickly look at change of states. What do you mean by change of states? The constant application of heat energy to a substance or a system result in what we call change of state. Matter exists in three states: solid, liquid, and gas. That was what we were taught. We were taught that matter exists in three states: solid, liquid, and gas. But recently we have discovered that matter exists in four states. We have solid, liquid, gas, and plasma. However, at your level, we treat matter at only the three state level. Plasma will be taught at your A level in what we call plasma physics. So in this video, we'll concentrate on the three states of matter, and we may just we may just look at a superficial treatment of the other states of matter. So for the sake of your notes, kindly go to this video quickly if you intend to. These slides quickly if you intend to. So I want you to take note of these things quickly. When the temperature is below 0 degrees, we have ice block. When the temperature is from 0 to 1 degrees, we have liquid. And when the temperature is above 100 degrees, we have gas. Water boils at 100 degrees Celsius. So what do we mean by change of states? Change of state is a physical change in matter that is enhanced by addition. This is very, very important. Addition or removal of heat energy to or from a substance. It is a reversible change that does not involve change in matter's chemical makeup or chemical properties. Process involved in change of states. Before a substance undergoes a change of states from one state to another, it passes through different processes, and these include fusion, freezing, vaporization, condensation, sublimation, deposition, ionization, deionization. This is a picture of change of states. Those processes are this: arrow down, arrow up, arrow down, arrow up. This is solid, this is matter. I told you matter is anything that has mass and can occupy space. So let's suppose this matter is ice. Let's call this matter ice. So this is our ice block. So if this ice block decides to change from solid down to liquid, we say that is melting or fusion. And if the heat energy is removed, mind you, when heat is added to this ice, it will change from solid down to liquid. And when we remove the heat energy, it will now change from liquid to solid. We call it freezing or solidification. Now, if I continue to add heat to this matter, this ice, I refuse to remove the heat energy, it will change from liquid to gas, and that process is called vaporization. If I decide to remove the heat energy, it will reverse back to liquid. It is called condensation. And then some matter changes from solid directly to gas. We call this deposition, and then some from gas to liquid. Let's look at this other diagram. This one involves the fourth state of matter: solid, liquid, gas, plasma. So this energy in, energy out. Meaning if you add energy up, If you add energy to change to if you keep adding energy to this system, it will change from here to here. We call it melting. If you add energy, heat energy again to the system from this to this, it will now vaporize. We call it vaporization. And if at this stage you keep adding heat energy, it will now go to plasma, and that process from gas to plasma is called ionization. If you decide to remove this heat energy, it will come down to what is called deionization, back to gaseous state. And if you remove this heat energy from gas again, it will come to this stage called condensation, back to liquid and down to freezing, down to solid again. And then the cycle goes on and on and on again. So to move from solid straight to gas, we call it sublimation, and to move from gas straight to liquid, to solid, we call it deposition. I hope you enjoyed this class and you probably understood what I just explained here. So let's move on. So this is fusion. Just you can screenshot this or pause it and copy down your notes. What I just said, this is it in words. Quickly go to it. Quickly, quickly, quickly. Kinetic molecular theory. Kinetic molecular theory tries to explain what happens that gives birth to what is called change of state. It is believed that all matter comprises of molecules, atoms, and molecules that are held together by what we call in physics intermolecular forces, also in chemistry intermolecular forces. And so when you add heat to the system, you try to break the bond that is holding the molecules of that atom of the matter together. And then when the bonds are broken, that is when change of state starts to take place. This is simply the kinetic explanation of the kinetic molecular theory. So the famous molecular theory of matter assumes perfectly that matter is made up of atoms and molecules. I just said that. You know what an atom is, you know what an element is. So let's move on. That molecule is a group of atoms of the same or different element joined together in a simple proportion. So we all know what molecule is. So let's move on quickly. So quickly go through this thing. These are the things you need to just pause and read, pause and read. I will explain the areas that are very important. Very good. The kinetic molecular theory assumes the following. One, every substance is made up of tiny particles called molecules. Number two, the molecules of the substance are in constant state of random motion, colliding elastically with each other and with the walls of the container, and hence constantly changing direction with which they travel. There is always an attractive force between the molecules. I explained this. I just explained, done explaining this. The volume of gas molecule is negligible compared with the volume of the container. So this is kinetic molecular theory I just explained earlier. This is it here again. So as heat is added to the system and the intermolecular forces are broken, the molecules of the system gains kinetic energy and then move randomly with colliding with each other and then with the walls of the container. In that process, they move and then they start moving from one state to another because they have been liberated. They have been held as slaves by the intermolecular forces. But thank God for heat energy that comes to set them free. So you can see that heat energy is a liberator of the molecules of an atom held together as slaves by intermolecular forces. So let's look at this quickly again. So we want to look at modes of heat transfer. Modes of heat transfer. There are various modes of heat transfer. The difference in temperature between two bodies causes heat energy to move from one body at high temperature to another body at low temperature. This flow of heat from a body to another body take note of this. I may ask you, What makes heat to flow from hot to low temp to hold from hot to low region? This is due to temperature difference. It's termed heat transfer or transfer of heat. This transfer of heat can happen in three ways: conduction, convection, radiation. So let's look at conduction. What do you mean by conduction? Conduction is a common experience that when you dip a silver spoon into a frying pan with a hot oil, you see that if you pick your spoon and dip it inside the hot oil, maybe for like 2 minutes or 4 minutes, and then you go back with your bare hands to touch it, you will do like this. Yet your hand is not physically in the oil. What is that? We call it what? Conduction of heat energy. So quickly go through this, then I will explain. This is what I'm saying. This is your candle burning, and then this is a metallic object that is placed on top of the flame of the candle burner. I mean, on top of the flame of the candle. And then you see this reddish color here, that is heat. The heat is now flowing from hot region to what? Cold region. And guess what? This guy is just holding this thing here because the heat has not reached here. Maybe like let's give him 2 or 3 minutes, he will drop this and then this thing will fall to the ground. That is what we mean by conduction. Conduction is just what you see here. So let's explain the other one. So we're done with conduction. Let's look at everything you see in that diagram is just here. Let's look at conductors. Now, why are we discussing conductors under conduction? We keep saying that conductors are also good conductor of heat and electricity. Every object that conducts electricity is also a good conductor of what? Heat energy. And so conduction only takes place in conductors. Conductors like metals, which we have the class iron, silver, aluminum, and copper. They are good conductors of heat and also electricity. So that is why we're discussing conductors in this topic. So you may be asking, why are we treating conductors here? This is the reason. So conductor is anything that can conduct heat and also electricity. So the ability for a conductor to conduct heat, we call it thermal conductivity. So that is what you just see me explaining here, thermal conductivity. So let's quickly move on. So I said it earlier, copper, aluminum, and silver, they are all good conductors of heat energy. And then wood, plastic, clothes, and then cotton wool are poor conductors of heat energy. If you touch this and this and this, take it close to heat, you won't see any effects. Want to look at the practical application of good conductors and poor conductors. This is it here. For good conductors, they are used for cooking utensils. You cannot use a poor conductor as pots. If you do, your food will remain there forever. So that's why we use conductors. We use pots that are made of conductors in cooking. We also have use of rugs on the floor. Now, when you put rug on the floor, it bridges. It serves like an insulator between your feet and then the floor, and then it also saves you from electrocution or extreme cold. Then home cooling in tropics, the uses of clothes to keep us warm, and then the uses of plastic insulators. We explain this all in all these slides. This is what I mean here. I don't need to go to read it out for you. Just go through it quickly and then you will understand what I'm talking about. This is it. This is it. Wow, let's look at convection. This is a form of heat transfer which normally takes place in fluids. Convection takes place in fluid. It's a form of heat transfer where molecules are heated down and then they rise up and then they come back again and then they keep flowing round and round and round. We call it convection currents. You can also find convection current in the core of the earth. So let's quickly have a look at this quickly. Please go through this. Very good. So let's move on. Let's move on. The diagram, behold the diagram. I want to use this diagram to explain that. Now, in convection, the red arrow stands for hot molecules which have gained kinetic energy at the bottom of the spot. And so they rise up, and as they rise up, we say hot molecules, they are less condensed. Hot molecules are less condensed. And then because less condensed will mean they are less heavy. So they have the ability to rise up. And then they rise up to warm the molecules at the top here, which are not as hot as this one. And then they now come back again. So the process continues up, down until the entire body of water start boiling. This is what we call convection. You can find convection in nature, in what we call land and sea breeze, which we'll also look at in this video. So this is land and sea breeze. Quickly go through this. Land and sea breeze. Very good. What do we mean by land and sea breeze? Pictures are self-explained. This, as I just said in convection, I said it here that in convection, the red arrow stands for the hot molecules which move up and then move down. So it is believed that in nature, during the day, this is during the day, down here is during the night. During the day, hot molecules, that is warm air from land, rise up and comes to the sea, and then cool air from the sea moves to replace the hot air. And so it is believed that it is cool in the daytime. It is cooler. If you sit close to the sea in the daytime, you feel cool here. Do you feel cool when hot air is? Yeah, you feel cool. You feel cool. Yeah, you feel cool. Now down here in the night, what happens? The hot air that went to the sea in the daytime reverse. This is clockwise movement of heat of warm air and cool air from the sea, clockwise. Then in the night it is reverse, anti-clockwise. Just take the sense, clockwise during the day, anti-clockwise during the night. Then warm air from the ocean comes back to the land, and then cool air from the land go to the ocean. So it is believed that if you go to the ocean in the night, you feel very cool, and then here feels very warm. So this is convection in nature. We call this thing, what you see here, convection currents. Radiation. You don't need to go to the sun or grab the sun before you get warm. You can't dare it. The sun will tear you to pieces. You will burn to ashes. But even here on earth, on a hot sunny day, we cannot just bear the heat of the sun. What is that? Radiation. The sun energy reaches us through what we call radiation. And this is what we explain in physics as scalar quantity. So heat is a scalar quantity that has no direction. It is an example of a scalar field or scalar forces. That is scalar force field. Very good. Force field are forces that touch you at a distance. You feel their effect at a distance. So the sun, the rays of the sun reaches us down here through all this phenomenon. So you don't need to touch the sun before you get warm. But also, if you sit close to the fire, You don't need to touch the fire before you get warm. Just a very close distance, and then you start sweating. We call this thing radiation. So let's quickly go through this thing quickly. Radiation is a process by which heat energy is transferred from a hotter to a cooler place without heating of the intervening medium. You should note that in radiation, no material medium is required, but convection and conduction do require a material medium for heat transfer. So a practical example of radiation is the heat from the sun, which I just explained. So this is what I'm saying. So what do we mean? Hence, we can say that the heat energy given out by radiation is known as radiant heat. Radiant energy or radiant heat. If I were you, I would take note of this. Such a radiation is an electromagnetic radiation of the type called infrared. It travels with the velocity of light. This 3 times 10 to the power 8 meter per second. So this is what I mean by radiation. You see this? The heat radiates in different direction. If you stay here, you get warm. You must not touch it before you get warm. You stay here, you get warm. You stay down here, you get warm. If you stay here, even here, you get warm. Any place you stay, you will get warm. So this is what we call radiation in nature. So emission and absorption of radiation by different surfaces. It is believed that black bodies absorb radiant heat, while white or reflecting bodies emit radiant heat away from them. It is for this reason that we don't like putting on dark clothes during hot season. As for me, I have a dark shirt I only put on when I'm catching cold. It is wool, but I only put it on when I'm catching cold. So as physics student, it is imperative you know these things so that you use your physical knowledge in physical science to relate with nature friendly. Don't put on your dark clothes during hot season. If you go to the north, they have very hot weather there. That is why you see them always putting on white agbada always. Then other people in other countries who are very wise, they don't live in dull color houses. They live in bright colored houses that pushes the radiant heat of the sun away from them so that they can have a good temperature that will not destroy their health system. So that is what we mean by this. So quickly go through this thing and then you see what I'm talking about. So I just explained this here. Black surface emits or radiate heat the most, and then they also absorb heat the most. Polished surface on the other side radiate heat the less, and then also absorb heat the least. So this is what I mean by what I just explained. So advantages of radiation, I just explained that how you can wear your clothes, how you can dress during the day. When it is hot, you know what to put on. Wow, this is what I mean. So to this we have come to the end of this class. In your new school physics, exercise 4, page 55, and then page 56, help me attempt all these questions. In summary, we define heat energy as a form of energy that flows from region of low temperature to region of high temperature. We say that when heat flows through a system, there is a change in temperature. And then in defining heat, we also make mention of temperature. And then we say temperature is the degree of hotness or coldness of a body. It is measured in the degree in the SI units of degrees Celsius, Kelvin, and degree Fahrenheit. The instrument used in measuring temperature is called thermometer. We also look at various effects of heat on the system. That when heat is added to a system, there are a lot of changes we have change in temperature, change in state, thermonic emission, increase size as expansion. We have change in chemical properties and also increase in pressure. We explained we explained change of state, and we stated three states of matter and also four states of matter. We explained them with this diagram you saw in this video, and then we also laid emphasis on what happened during change of state. Those processes were also explained. So I'd like you to go back and replay this video, and then if you are not too clear, you pause, and then the slides are made here deliberately for you to understand. I believe you enjoyed this class. Stay safe and stay blessed. God bless you. Thank you for giving me your time.